Hey everyone, this is Ethan from Past That Class, and today I'll be teaching you guys how to name chemical compounds. Now this is one of the most important topics whether you're in honors chemistry or AP chemistry, because you're always going to need to know how to go from the chemical formula to its name and back from the name to the chemical formula. And this is also important because if a teacher were to ask you to get a specific chemical from the storage room and all the labels show only the chemical formula, you want to make sure that you get the right one, because if you end up using the wrong chemical in the lab, it could be potentially dangerous. So for this video, I'm assuming that you guys already know about the periodic table and where the metals and nonmetals are. So let's get started. For naming pure metals and nonmetals, these are just elements straight off the periodic table. And what you want to do is just take the name that's right over here on the periodic table. So if we were to take Na, the name would be sodium, and that's it. You don't have to change anything, you don't have to do anything to the name, it's just the name that's right there on the periodic table, because there's nothing fancy with this, it's a pure element. Same thing with the nonmetals here, we have C, so we take that and look at the name on the periodic table, which is carbon. Alright guys, let's take a look at ionic compounds now. So ionic compounds follow a set of rules that are going to be the same always, and there's two sets of rules actually. First, we're going to take a look at what we do when we have a metal in our compound that has a constant charge. Now first, let's talk about ionic compounds. They typically follow the pattern AB, where A is the metal and B is a nonmetal. So let's do NaCl as our element or compound right now. And the first step, what you want to do is take the metal off the periodic table, the name. So that would be sodium. And then second, you want to take the name of the nonmetal, which in this case is chlorine. And after that, you want to drop off the ending and keep just the stem of this. So it would be chlor. And finally, you want to add the ending IDE, so it'd be chloride. And then you put that together, and you get sodium chloride. Now, this works perfectly because sodium over here has a constant charge of +1. But if we were to take something like a transition metal, such as iron, which has a variable charge, it wouldn't work the same way. So I'm going to erase this, and let's take a look at Fe2O3. And in this case, iron here has a 3+ charge, and oxygen has a 2- charge. Now, if we were to name this, like we did the previous way, we would take iron's name, because that's the first metal, and that's the name on the periodic table. And second, we would take the name of the nonmetal, which is oxygen. Oxygen. And then we want to drop off the ending again and just keep the stem, like that. And add the ending IDE, so it would be oxide. So now we would have iron oxide. But if we were to take this name and go to the chemical formula, it would be Fe and O, and we know that oxygen has a -2 charge, and we don't know the charge of iron here, and that's because iron can be a variable charge, so it could be either +3 or +2. So what we actually want to do is, since we know the charge is 3 over here, when we write the name, we're going to take iron oxide like we did before, but right after the name of the metal, in parentheses, we want to put Roman numerals for the charge. So we'd put 3 like that, and it would be oxide. And now when we take a look at trying to write the chemical formula, we take iron, we know it's a 3+ charge, we take oxygen, and we know it's a 2- charge, and we just cross the two charges, so we get Fe3O2, and we get our chemical compound. So that's pretty much it for naming ionic compounds. There's two separate ways. You just have to remember that when we use metals that have variable charges, you want to make sure that you include this Roman numeral here in the middle. But if your metal in the compound has only one charge, it's a constant charge, and it can only be that constant charge, do not include the Roman numerals. So if we had sodium again, and it only has a +1 charge, we wouldn't write sodium 1 chloride, because that would just be wrong. You want to take out those Roman numerals. Now let's take a look at naming non-molecular compounds. Now, naming non-molecular compounds have a few different sets of rules because these actually use prefixes. So let's take a look at them. When the element in our compound has only one of them there, it'll have the prefix mono. 2 would be di, 3 is tri, 4 tetra, 5 penta, 6 hexa, 7 hepta, 8 octa, 9 nona, and 10 deca. You just have to memorize those when you're naming the chemical compounds. So let's take CO2 for example. There's also one exception to this rule. If the first element in your compound has only one of them, then you do not include the prefix mono. You just take the name straight off the periodic table, which is carbon. But if the second one is 1, you would include the prefix mono. But in this case, there's 2 oxygens, so it would be di, and then you take the stem of the second element, which is ox in this case, and add the ending IDE, just like we did for our ionic compounds. So that's pretty simple. Let's take a look at another one, S2O3. Now here, the first one has 2 sulfur atoms, so we want to take the prefix di, and then the full name of our element on the periodic table, which is sulfur. Then oxygen has 3, so we use the prefix tri. We take the stem of it, which is ox, and add the ending ide. So disulfur trioxide. And that's pretty much it for naming non-molecular compounds. It's easy. All you have to remember are these 10 different prefixes. You also have to remember that if the first element in your compound has only one of them, you do not include the prefix mono. It would not be monocarbon dioxide. You drop it and you just have carbon dioxide. So that's pretty much it for this video, guys. I hope you enjoyed, learned something new. If you have any suggestions for future videos, please leave them in the comments below. And thanks for watching. Check out our other economics videos and calculus videos as well. I'll put a link in the description below to another video I'm making on how to name acids and bases. So thanks for watching, guys.